In my last video, I turned a bunch of rusty stock into something that looks like a vise for my Rhodes Shaper. In this video, I'm going to turn it into something that works like a vise too. Parts like this that have a flange on them are always kind of a pain because you end up with a really big piece of stock that you have to turn down really far. But I found this crusty piece of axle that already has a pretty good flange on it. A little bit of run out in that. We'll get it cleaned up. I've got this all roughed out now, but I'm really struggling to get any kind of decent surface finish on it. I suspect part of the issue is the crusty bit that I'm holding it on, and now that it's small enough to fit through the spindle bore, I'm going to flip it around and clean that up before I do the finishing on it. Carbide tool works okay, but the winner was this high-speed steel tool that's basically just all radius. Leaves a pretty good finish. The issue with the big radius is it leaves a lot here that I need to go back and clean up with something with a smaller radius on it. This one is the bearing surface in the vise, so I'm going to polish it to final size. Now, of course, I need to cut an acme thread on here, which, given how gummy this is going to be a bit of a challenge. Let's see what we can cook up for a thread tool here. On a threading tool like this, if you put rake on the top of the tool, it screws up the geometry of it. So instead, I just gave it a lot of relief in the hopes that that gives me a nice sharp cutting edge to cut into this stuff. Let's see if that theory works. Last few very light passes here, spring passes. I can feel a very tiny burr. Actually, it's not even really a burr, it's just the hard corner there. You see a little bit of kind of chatter marks way down in there. I've done a few of these now, and honestly, this one came out way better than most of them. I'm just going to break those corners with some emery and call that really good. And through the magic of nonlinear editing, I'm already set up to cut a 7/8 hex on this. Made a washer to fit right in this little pocket. And then I have a bunch of these old nuts that I salvaged. Cleaned it up a little bit. I think that looks the part pretty well. I'll have to Loctite this when I do the final assembly so that it doesn't tighten down too much. I might as well use up some more of this axle. I know it's not the best material for this, but you people seem to like it when I do this stuff. I got this thing cleaned up a little bit with the needle scaler and wire wheel. Let's get rid of that carriage bolt and start squaring it up a little bit. So what I need to do is turn this into something that's going to fit in here. And it needs to have clearance around the sides and bottom, and then register on the top surface and in this slot. I think the most sensible thing to do is to cut the clearance surfaces first and do all of those in one setup on the rotary table. Second side, same as the first. Took a couple more passes that I didn't show, but this thing fits pretty well. I'm just going to use a clamp to hold this up to the top of the vise so it's nice and tight, and then transfer punch it. So the next thing to do is going to be to bore this out and thread it, but before I do that, I should make a threading tool for it. I've done a few of these now, and I keep refining my technique for doing them. I've got a piece of 01 tool steel offset in the 4-jaw chuck because I really only need the tooth on one side, so I'm only threading it on one side. And I'm cutting a thread that's a little bit coarser than the final thread will be. I cut this thread about 100 thousandths deep, so I should have plenty of clearance to work with. And now I'm going to go in and knock off all but one tooth. I think I'm going to go for the second tooth. It looks a little bit better than the first one. Now I'm just going to square up the back side of this tooth. Basically, the idea here is I'm baking all of the clearance angles into this as I make it. So the last thing to do here is to get the width of this right. Right now I'm at about a 6. I want to be about an 8. So look up in the machiner's handbook the difference between those. It's 15 thou. Use the indicator on the carriage stop. Yeah, that's good enough for what I need. Since this is a pretty terrible setup, I'm going to take this down to a few thousandths over half and knock the last little bit off on the grinder after I harden it. If I'm going to fire up the heat treat oven to harden this, I might as well do the vise jaws at the same time. This is some 4140, which I feel is a good balance between hardenability and price. It's a little cheaper than using a tool steel. The jaws on these look pretty thin. I'm going to call it 3/8. With the jaws this thin, there's not room for a normal socket head cap screw in here. I looked for low profile ones. They're available from McMaster-Carr for about $13 a piece. That's not going to happen. I could use a flathead like this, but I don't want it to be pulled into place by the screw. I want the bottom of it to be nice and tight against the bottom of the vise, so the tops are always the same height. So now I need to come up with some screws for this thing. I think that should work. There's never really any force pulling up on this. It basically just needs to keep the jaw in place when the vise is open. So it doesn't need to be much. Hang on, let me check something here real quick. Oh, here it is. Fascieri multiplicatum. This is boric acid paste. It helps prevent scale when you're heat treating. I made two miscalculations here. One is the 4140 needs to go to a higher temperature than the 01, so I have to fish this piece out from underneath some hot metal. And the other is this stuff gives off some pretty nasty fumes, so I just opened up all the doors and let it air out while I was doing this. The boric acid made these a bit easier to clean up than usual, but I'm not really sure that it's worth the fumes. The hardness guesstimator files say both of these ended up probably somewhere between 50 and 55 Rockwell. So I'm not going to bother tempering them. I wish they came out a little harder. That might be the hardest thing I've ever had to true up in a 4-jaw chuck. That existing hole is causing me problems because the hole I'm trying to drill isn't centered up on it. Let's try knocking it out with an end mill. See if I can get a drill bit through there now. Now I can get in with the boring bar and try to make this hole straight again. It's just that easy, right? Except, of course, it wasn't actually that easy. Because this tool wasn't hardened properly, it wouldn't stay sharp, and after stoning it back into shape a few times, in a fit of desperation, I heated it up with a propane torch, quenched it in some water, and that made it really hard, but it also made it really brittle. And you might have noticed I made the classic mistake of leaving a really hard inside corner on it. So, of course, as soon as it hit the work, it snapped off. And since I know somebody's going to say it, why not just grind it out of high-speed steel? That's a lot of grinding to do for a very small feature that needs to be done fairly accurately. And the ones that I've done this way in the past have worked well for me. But I had another threading tool that I made for doing a 10 TPI thread. Managed to finish it up with that. But because the flat on the end is a little bit narrower, I had to walk it back and forth. At that point I was basically flying blind, doing it by feel, doing a lot of checking. But I eventually got it. And I think I learned something there. I left a bunch of extra material here thinking I might want to hold on to this at some point. I think I'm going to hold it on the bottom, so I'll knock that off. Good thing I got that cut off nice and square. I haven't brought the jaws down to final height yet because I want to do it with it in place here. There's really no reason to grind these to the same thickness, but there's no reason not to either. Of course, on the height, I do want them ground to match. I'm not sure why you'd ever need to do this, but you can. So the capacity of this is only about 3 inches, about 75 centimeters. But what I can do is swing this around, pop this one off, and then I can move this jaw to the outside. But with these thin jaws and these little fasteners, probably don't really want to be pulling against that. But if you remember from my last video, I planned ahead for this sort of situation. I'll need to get a shorter cap screw for this side. That one's bottoming out. But you get the idea. So now if I push it probably farther than I should, I can go the entire 7-inch range of the shaper. You get the idea. Overall, I think that's a neat little compact vise for this shaper. I'm excited to put it to use in some other projects, so if you want to see that, you know how YouTube works, stick around. That was a lot more involved of a project than I thought it would be, so right now I'm just really glad to call this thing done.